we have gone straight to the edge of the event horizon and seen the point of no return. For the past 2 decades, a global collaboration of scientists around the Earth have been putting together an Earth-sized telescope with a single purpose: to image a black hole. And now we have done so.
Right, we have done something extraordinary. We've made the first picture of a black hole. If you want to make a test of the fundamental theories of the universe, you want to go to the most extreme laboratories in the universe. And a black hole is that.
This is an extraordinary moment in science. It's the best verification that we have that black holes aren't just theoretical scribblings on a blackboard, musings of theoretical physicists, but real entities roaming the universe.
We all understand from a mathematical point of view that black holes exist, but to actually see something is a very visceral experience, and I think important for science and also for us to believe in it.
The black hole that we've imaged is M87. This is a behemoth. It's a black hole that's 6.5 billion times as massive as our sun. And it sits in the center of a galaxy 100 times larger than our Milky Way, which itself lives at the center of a cluster of thousands of galaxies, Virgo. They are quite literally gravity run amok, a key window into one of the least understood and yet most omnipresent forces that we are all faced with: gravity. This provides the first time that we're able to study in detail the stage that gravity sets for astronomical phenomena.
I think we've been extremely lucky. I'd expected that we have to work for years and years, do many observations until we get a final image. And then we look at our first source and we see that ring. We see the event horizon and we see that shadow, that dark region. And you know immediately we're looking at an event horizon and a black hole from all sides at once in this thing. We see at a region where time stops. This is a very different part of the universe that we're seeing for the very first time.
The most striking feature in these images is the footprint of gravity. This ring-like feature with a central dark depression, the shadow of the black hole. That region where the photons that we see would have had to have come from below the horizon and are therefore absent.
It's amazing to be able to work on data which have never been obtained before. To have highest resolution observations, this is a unique time for a scientist in his or her life to work on these kind of data. So to see into an area where we didn't have any information before.
This first image doesn't represent the end of an endeavor, but rather the beginning of an era in which we have a new key window onto how gravity behaves and how it shapes our universe.
The future of this project is amazing. Now we want to make the first movie. Now we want to understand how space-time rotates around the black hole. We'll do that by putting more telescopes around the world to make our virtual lens even better.
It signals the beginning of this new era in which we can study the life and times of these extraordinary objects in a way that was simply impossible before.
One of the most uplifting things for me is the team that we've built and the fact that we're doing something that people have told us was impossible. And when you, at the end of the day, do something that people tell you you can't do, it's an incredible feeling. And I think the whole team is very, very proud that we've accomplished something like this. It's not just for us, it's for everyone.